Now in this case you can see that VB is less than VR. So this boat cannot have a zero drift, which means that this boat cannot reach from A to B directly in any case. Now we know that in this case zero drift is not possible, so there would be some significant amount of drift. Now that drift is needed to be calculated, and we need to minimize the drift. Okay, so again, if we wish to predict that in which direction he should try to row the boat, in 1 or 2 or 3, so we can easily predict that. Now again we need to minimize the drift. So to minimize the drift, we need to go against the river flow, but not exactly against, because in this case we would not able to cross the river. So we need to cross the river also, and we need to minimize the drift also. So the direction of this boat velocity should be like that, somewhere at an angle of theta. Now we wish to find out the minimum drift, and we wish to find out the angle theta for which that drift would be minimum. So we know that if VB is less than VR, then obviously the component of VB, which is VB sine theta, would be less than VR. Obviously, this is quite obvious. So the x velocity of the boat, Vx, would be equal to VR minus VB sine theta, because VR is greater than VB sine theta. So the net velocity of the boat in x-axis would be VR minus VB sine theta. And if the width of this river is W, then we can say that the y velocity of the boat would be this one, VB cos theta. This would be the y velocity, VB cos theta. Now we have already discussed that the time this boat would take to cross the river is depending on the y motion only, and in y direction you can see that the distance which this boat has to travel to cross the river is W. So the time would be W upon Vy, which is VB cos theta. Now this is the time which this boat would take to cross the river, and obviously due to the effect of river velocity, this boat would reach at this point, which is at a distance of del. Now we need to minimize this drift. First of all, this del is the displacement of the boat in x-axis along the direction of river flow. So this del can be calculated by the fact that it would be the product of the net velocity of boat in x-axis and the time taken by the boat to cross the river. So del will be equal to VR minus VB sine theta multiplied by time, which is W by VB cos theta. So del would be equal to W by VB cos theta into VR minus VB sine theta. Okay, now we need to find out the value of theta for which this del would be minimum. So we are using the technique of maxima minima. So d del by d theta will be equal to 0. So let us differentiate this one. So this would be d by d theta of VR minus VB sine theta divided by cos theta. Okay, so we just need to find out this differentiation and we need to equate it to 0. So I am not writing these terms, so I am writing just the derivative term. So this would be cos theta into minus VB cos theta, and this is minus VR minus VB sine theta. In fact, I would write it on the next page. Okay, so let us take another page. Now d by d theta of, I am writing it down again, VR minus VB sine theta, VR minus VB sine theta upon, this is cos theta. So let us differentiate it and we can use the u by v rule. So you can see that cos theta into VR, differentiation of VR is 0, and this is minus VB cos theta minus VR minus VB sin theta into the differentiation of cos theta is minus sin theta, so it would be plus. And I'm not writing upon cos square theta because it has gone into 0. So this is 0. So this is minus VB cos square theta plus VR sin theta minus VB sin square theta, and that is equal to 0. So VR sin theta is equal to VB cos square sin square would be 1. So sin theta, you can see that sin theta would be equal to VB by VR. Now you can, this is the angle at which this boat should be rowed so that it reaches with the minimum drift, but drift would not be 0. Obviously you can see that in this case also VR would be greater than VB, because in this case sin theta is equal to VB by VR. So now to find out that minimum drift, we can substitute these values into this expression. So in fact this one, so it is W by VB cos theta. So del minimum would be W by VB, and cos theta will be equal to under root of VR square minus VB square by VR. So this is cos theta, and it is under root VR square minus VB square by VR. Okay, in fact it is in the denominator, so I would write it in the denominator. So it would be VR upon under root of VR square minus VB square into, now this is VR minus VB sin theta. So it is VR minus VB sin theta is VB by VR. So you can see that VR would be cancelled out, and del minimum will be equal to, see, we would take the LCM, and the term would be under root of VR square minus VB square in the numerator, and in the denominator there would be a term of VB, because this VR and this VR would cancel out. So this is the minimum drift of the boat with which it would cross the river. So this was the case of minimum drift, and in the next video I would be bringing the high level and level 1 numericals of this river boat problems. Thank you.